I discovered all of these clusters in May and June 1764. All of them are located approximately towards one direction, being projected onto Ophiuchus constellation and rich star fields of the Milky Way as well. M9 is located pretty close to the galaxy's center, separated by 25,800 light-years from us. Its overall luminosity is about 120,000 that of the Sun. We know about 13 variable stars in M9. It resides at a speed of 224 km per second.
With a 10-feet reflector and a magnifying power of 250, I see several stars in it, and make no doubt a higher power and more light will resolve it all into stars. This seems to be a good nebula for the purpose of establishing the connection between nebulae and clusters of stars in general.
M10 turned to be 83 light-years across, located at a distance of 14,300 light-years from us. There are 4 variable stars in it. M10 cycles around the Milky Way's center each 140 million years. It crosses our galaxy's plane each 53 million years. M12 is separated only 3 degrees from M10 on the sky, what turns into a difference about 1700 light-years. Diameter of this cluster is about 75 light-years. M12 can be distinguished from the other globular clusters because it is too open, and it was often taken for a real open cluster. On the 14th of August 1774, I discovered in Ophiuchus 2 new nebulae not far from each other. One of them is situated south of 14, 16, 19 and 21 Ophiuchus near the western arm, the other below this one and eastward, closely west to the 13th of Ophiuchus. These nebulae appear very pale, and because of this I found not very reliably the separation to lambda as 6 degrees 7 minutes, to the star 14 as 3 degrees 50 minutes, and to the 21 as 3 degrees 32 minutes. A study published in 2006 concluded that this cluster has an unusually low number of low-mass stars. The authors surmise that they were stripped from the cluster by the tidal forces of Milky Way galaxy. There are 13 variable stars in Messier 12. Located at a distance of about 30,000 light-years, M14 contains several hundreds of thousands of stars. The shape of this cluster is decidedly elongated. M14 is about 100 light-years across. It can be resolved by amateur telescopes and contain more than 70 variables.
Extremely bright, round, easily resolvable. With 300 I can see the stars. The heavens are pretty rich in stars of a certain size, but they are larger than those in the cluster, and easily to be distinguished from them. The cluster is considerably behind the scattered stars, as some of them are projected upon it.
In 1938 a nova appeared here, although it was not discovered until photographic plates from that time were studied in 1964. It was over 5 times brighter than the brightest normal star in the cluster. In 1997 a carbon star was discovered in M14. This star has probably lost its outer layers in close encounters with other cluster members, so that the carbon-enriched former core reaches up to the surface. M19 is the most oblate of the known globular clusters. It is at a distance of about 28,000 light-years from the solar system, and it is quite near to the galactic center, at only about 5,200 light-years away.
It will not be necessary to add that the 2 last mentioned globular clusters M19 and M53, viewed with more powerful instruments, are of equal beauty with the rest, and from what has been said it is obvious that here the exertion of a clustering power has brought the accumulation and artificial construction of these wonderful celestial objects to the highest degree of mysterious perfection.
So here what they are, the snowballs of the serpent bearer.
suivi.